Whether it is by scientific interest, to answer philosophical questions, or to try to give a bogus meaning to astrology magazines, humans have always been interested about space. And one of the main questions about space is, of course, is there life somewhere else in the universe? So it is widely accepted that life, at least in the form that we know it on the Earth, needs liquid water to exist. So this means that the planet needs to be in the habitable zone of its star, so at an ideal distance where the star provides enough energy for water to exist at liquid form on the surface. If the planet is too close from the star, the water will turn into gas, and if it is too far from the star, it will turn into ice. Okay, so what life needs to exist is liquid water, but what it needs to develop is energy. And there are various hypotheses that try to explain where this energy came from in the case of the Earth, and where it could come from in the case of other planets. My research focuses on one of them, stellar activity. So although stars can be viewed as just giant balls of plasma, they almost behave like living things. They move, they rotate, they expand, they shrink. In short, they evolve. And some stars can even do more. They are called the active stars. And the active stars are composed of very turbulent plasma that makes bubbles, filaments, loops, and other very artistic things that would make the best Windows backgrounds. But even though they are more beautiful, the active stars are also more dangerous. Because they are so active, they are also more unstable, and sometimes small explosions can happen on their surface. These are called flares. And during flares, an enormous quantity of energy is released, similar to millions of nuclear bombs happening at once. The Sun itself produces flares, but we are on a 365 days orbit, so we don't feel their effect too much. But imagine if you are on a 10 days orbit, for example. What effects will these flares have on the surrounding exoplanets? The TESS satellite has been launched in 2018 precisely to study this. It has shown that, unfortunately, most of the times the energy produced during flares is enough to completely sterilize the surface of surrounding exoplanets. But in a huge amount of data gathered by TESS, a very small fraction of it shows that for some stars, the energy produced during these flares is sufficient to provide enough energy to enable the conditions for life to develop. Indeed, when provided with the perfect amount of UV light, the mineral dust present on the surface of rocky planets can enter chemical reactions to turn into nucleobases that are the building blocks of primitive life. And that is why life needs energy to develop. So, are there other habitable planets in the universe? Well, TESS and the other satellites that will follow are our best shots at getting an answer in the future. In the meantime, what they do best is reminding us how perfect the conditions on Earth were for life to develop, how fragile it is, and why we should cherish it.